Good day everyone, I'm Jurex Wayne Siapan from 10 Newton along with my teammates Miguel Christopher Sarmiento, Rafael Jared Lose, and Sir Nicole Barbo, and we are the Team Biograsstics. We will be presenting our research study entitled as Scotch grass, or also known as Elimus repens, with eggshells as a bioplastic. And now, we will be starting from the statement of the problem. For the statement of the problem, the study is intended to determine if the mixture of the grass and eggshells can be used as a bioplastic to substitute non-biodegradable plastics and make it more durable and flexible. Specifically, it aimed to answer the following. Number 1, to make a bioplastic that is durable and flexible, and number 2, to determine the effectiveness of the mixture of the Scotch grass, or also known as Elimus repens, and eggshells to make a bioplastic.
Next is hypothesis. For the null hypothesis, the mixture of eggshells and Scotch grass Elimus repens cannot be used as a bioplastic. For the alternative hypothesis, the mixture of eggshells and Scotch grass Elimus repens can be used as a bioplastic. For the variables involved, the independent variable is the amount of Scotch grass Elimus repens and eggshells. The dependent variable is the biodegradability, solubility, and tensile strength of the bioplastic.
Hi everyone, my name is Miguel Christopher Sarmiento from 10 Newton, and I will be discussing our methods. So, all of this picture here are all parts of the process of making our bioplastic. So, the pictures here that we use is from setup A, which the measurements of the Scotch grass is 100 grams and the measurements of the eggshells is 50 grams. So, in the first picture, we can see the eggshells that is grinded through the use of mortar and pestle, and the eggshells weighs 50 grams. In the second picture, it should be to be equal to 100 grams, but I only include one because of the space in the slide. So, Scotch grass is the major problem of our study. Why? Because it's very hard to find, like to grind, because there is still some little pieces that little grass that mix up, that is very long, very short, medium short. Yeah, like 5 centimeter, 3 centimeters, and yeah, and it majorly affects our bioplastic because it doesn't even look like plastic at all. And yeah, let's proceed to the third picture, which is the tapioca starch. It weighs 50 grams. In the fourth picture, there is the glycerin that measures 75 ml, together with the fifth picture, which is vinegar that also measures 75 ml. And in the sixth picture, all the materials have been put together, and the list of it is 200 ml water, which I didn't include in the slide, 50 grams tapioca starch, 50 50 grams eggshells, 100 grams Scotch grass, 75 ml glycerin, and 75 ml vinegar. In the seventh picture, we all mix it up in a cauldron with a low heat for about 2 minutes for it to mix well, and after 2 minutes, we spread it in a flat board for about 3 days for it to solidify. And yes, that is all. Thank you.
For table 1, it is the tensile of manufactured plastic and bioplastic. For the manufactured plastic, the tensile strength of first trial is 1 and the tensile strength of second trial is 2. For setup A, the tensile strength of first and second trial are 0. For setup B, the tensile strength of first trial is 5, the second trial is 1. For setup C, the tensile strength of first trial is 0.5, the tensile strength second trial is 0.3. And for setup D, the tensile strength of first and second trial are 0. 2. It is the biodegradability of manufactured plastic and bioplastic. For manufactured plastic, the measurement of biodegraded plastic in millimeter for first and second trial are 0. For setup A, first and second trial are 0. Setup B, first and second trial are 0. Setup C, first and second trial are 0. Setup D, first and second trial are 0. Table 3, it is the solubility of the manufactured plastic and bioplastic. For manufactured plastic, the measurement of undissolved plastic in millimeter for first trial and second trial are both 25.4. For setup A, the first trial is 20 and the second trial is 5. For setup B, the first trial and second trial are 0. Setup C, first trial and second trial are 0. And setup D, first trial and second trial are 0. Table 1 and 2, there is no significant difference between the treatments since the p-value 0.24 is higher than the level of significance, which is 0.05. The computed f-value is 0.02680, which is lower than the f-critical 1.94, stating that the null hypothesis is accepted. Table 3 and 4, there is a significant difference between the treatments since the p-value is 0.0099 less than the level of significance, which is 0.05. The computed f-value is 0.07746, which is lower than the f-critical, which is 11.43, stating that the null hypothesis is accepted. Summary of findings. Based on the results of the experiment, the researchers determined that Scotch grass or Elymus repens with eggshells cannot be used as biodegradable plastic, and Scotch grass or Elymus repens with eggshells are not durable, not biodegradable, and soluble.
After conducting the study, the researchers therefore conclude that Scotch grass, Elymus repens with eggshells cannot be used as a bioplastic. No matter what amount of Scotch grass, Elymus repens, or eggshells is used, its properties still fails to achieve the requirements to make a good bioplastic. Based on our stats, all of the tests that we have made have accepted the null hypothesis, and even looking at the quality of the bioplastic itself, you can see that it's not durable, it's not biodegradable, but it is soluble. For the recommendations that I can give to future researchers, I highly recommend that you should thoroughly fine your grass, because the mixing of the bioplastic will depend on your grass. And I also highly suggest that you should find more alternative materials that can help strengthen your bioplastic. And that's all. Thank you.